Daniel Turner, who is founder and CEO of TRAXyl. And we're going to be talking in here to anywhere, closing the digital divide right now. I think that's a big topic. Pandemic obviously influenced that in several variations across different platforms and in different industries, but I'm going to back out of the way and let you take over.
Thanks a lot, John. It was great to see some of the space-related presentations earlier, and then most recently the underground drilling rig stuff. But I'm here to talk about our solution, which is neither below the ground or above the ground. It's called, my company's called TRAXyl, and I'm Dan Turner, the CEO and founder. And we're talking about closing the digital divide right now. So again, I'm Dan Turner, the CEO and founder. I graduated from Virginia Tech, have an engineering degree. And then I went to work for the federal government for 12 years, and I managed some very complicated technical projects and deployed teams to the field. And it really set the groundwork for the solution that I'm going to share with you today that will help close the digital divide. I have a co-founder and another part of my team is supporting me, and there's a bunch of advisors and mentors that we've gathered along the way. But I want to talk about the problem first, and that really is a problem of getting access. Now, most people think that 5G or some of these other technologies like space-related solutions are going to help close this digital divide and get access. But a lot of people don't realize that whenever you have antennas, you really need a lot of infrastructure and specifically optical fiber to help backhaul that data from those antenna points. And so it's this puzzle of how do you connect the ISPs, the antennas, and the optical fiber to bring access. And it's actually quite a large problem. I think something like $150 billion in optical fiber infrastructure is what's estimated in order to roll out technologies like 5G. Yet there's something like 75% of US citizens today don't have direct access to fiber or to the antennas that fiber will serve. And so that's really where our problem is addressing. And the reason that fiber is really the key to these technologies is it provides this huge amount of data bandwidth that can serve these antennas. But the challenge is getting that fiber in the ground. Now, traditionally, you can hang it aerially on telephone poles if the poles exist, or you bury it underground and you have to have a bunch of equipment to produce trenches and you have to dig, and it's a lot of manpower. It's very expensive. Anytime you have to cut into the ground, you never really know what you're going to run into. It's very disruptive as well. It can close roads for significant amounts of time. If you hit another utility and you're trying to avoid these other utilities that are out there, if you hit a water main or a gas line or something else, it can be very disruptive to everybody that's around you. And then once you cut into the ground, it's destructive, but now you have to repair and resurface the road, and it's just a mess, and it's very time consuming and very, very expensive, especially if you're in places that have a lot of rock, or again, you're in these urbanized, densified zones that have a lot of other infrastructure in the way. And so that's really where our solution comes in, and we call it FiberTRAX. Essentially, what we're doing is painting optical fiber directly onto paved surfaces without having to cut into that surface. And so we have these resins and fiber cables that we bond to the pavement. And we started off, my co-founder and I, crawling around on our hands and knees, trying this out, and quickly discovered that we really needed a machine to help us automate our new discovery, this FiberTRAX discovery. And so we built a machine that we call the FiberTRAXter that automates our installation process directly to paved surfaces. And I'll talk a little bit more about what that does. So this problem really started when my dad couldn't get internet out to his house. He lives in a somewhat rural part of Virginia. He asked the ISP to come out and bring him service, and they basically laughed and said, "You'll never get fiber out to where you are and where you live." But they used the road to drive out to my dad to tell him that. And so that's really how the idea began, is could we just paint a line using the road, not look at roads like obstacles, but really look at roads like the pathways to utilize. And so what this does by using roads is it provides a fiber installer a much more efficient means to bring a connection where they can almost install basically same day or on demand. And I have a couple case studies I'll talk about where we did that. But it adds a level of convenience and versatility that traditional installers can't use or can't rely on, because they're now using what taxpayers have already paid for, the road infrastructure. We're getting to dual use that road now and provide a pathway for digital communications like optical fiber. So what it is, this is kind of the cross section of what it is. It's not really paint. We're not just painting a line that provides connectivity. In essence, we are, but what it is we're taking a very low profile fiber cable. In this case, it's a 3 millimeter cable. We're bonding it to the surface using a very, very fast, quick curing resin that bonds in seconds. And we call that our elastic bond coat. And it's holding that cable in place. And then we apply a second coating, another resin. It's another quick curing resin, but something in the order of 20 to 30 minutes to fully cure on top, that is colored and blends that bonded cable to the surface and provides an extra layer of durability to the installation. And that's basically what it looks like from the side view. Now the thicknesses again are very, very low profile, and they're ADA compliant. They're about the thickness of a crosswalk paint line if you were ever to think about the thicknesses of those thermoplastics that they bond to pavement. So we're talking very, very low profile here. What this enables us to do is actually install in areas that have snow plows even. So obviously nothing's going to stop a snow plow if it's gouging into pavement, but by feathering the edges, ramping them, keeping the profile extremely low. We've actually had multiple installations that have had snow plows run over the lines and not cause problems. So we're pretty excited about being able to live in this new right-of-way that we've discovered, which is right on the surface of the road. So if you look at other conventional methods to bring fiber to places, you're either, again, putting them on utility poles, or you're trenching, or in some cases micro trenching, or boring, directional drilling underneath roadways to bring a connection. But with our solution, we still provide the same high capacity data. It's not any different than the other fibers and other cables. So you can still splice to it. You can still connect to an existing cable coming off a telephone pole, but it's aesthetic. It doesn't really ruin the view shed. You don't have to put up poles to bring a connection. And it's also safe to other utilities because we're not cutting into the surface or in our own right of way. It really shaves down on the potential damage to those other underground utilities that are already, filling up on the sides of the road. And it's on demand. So you can think about installations that can happen that same day. It's a very, very fast solution that brings a connection as quick as people need it to be. So again, looking at a notional installation of like a mile of fiber, we're looking at really reducing not just the fiber installation time period, but we think there's significant savings in time for the design and permitting process. You still would put the same junctions off the roadways in much the same way that you would a conventional installation, where we have to start and end a run, but there's no excavation during the installation. You're laying the fiber down on the fly. There's no backfill, there's no restoration. But then when you get to the terminations, that's all the same too. So you still are splicing or connectorizing those fibers in much the same way that you would conventionally. But again, you're shrinking install timelines significantly. Where we're kind of targeting our initial customers, we're looking at customers that have these densified urbanized areas, but maybe want to extend an existing network. So campus-like environments, apartment communities, bases, airports, anywhere that they have their own networks that they control and they own the surfaces, and they're really just trying to get a fast and immediate connection made. And that's really where we found the most luck with our initial customers. And again, we're trying to help standardize this technology. So we're looking for distributors and other channel partners to sort of broaden our reach and ability to connect to the end users ultimately. Part of our initial research was funded through the National Science Foundation, where we built a bunch of samples and put them in a chamber where we thermal cycled to extreme cold and hot temperatures. And then we also cycled the humidity. And then we built this wheel fixture that rolled back and forth. We had close to 700,000 impacts. And you can actually see the samples are starting to rut just from the sheer pressures and temperatures that we were seeing. And what we found with this, we were actually trying to cause failure so that we could predict an accelerated life of how long this stuff would last. But with a particular sample family that we built, we actually had no failures whatsoever. In fact, that wheel fixture probably failed, 10 to 15 times during our testing, and we had to repair it. But our samples continued to pass optical signal through and didn't have any failures at all, even with the rutting. So this really gave us the confidence to go out and install our product. We knew we were on the right path. We had something here, and so that's what we did. We built a early prototype machine. I built this in my dad's garage, and it was a 2-pass system, but it was something that we used to help a customer of ours, GigStream, an ISP, to deliver internet to 36 apartment buildings in Greenville, South Carolina. They did all the trench work and connections and equipment they mounted to the sides of the apartment buildings, but they had trouble getting across the drive aisle and parking lot in several locations because of a water main. They had a boring company come out and try to find and look to see if they would be able to do it. It was too risky. And so they found us, and we were able to make these 4 separate connections in a single day, to the point where they were actually turning on customers that next week and getting them high-speed internet service. And I'm sure, all through COVID and even now to this day, that this is still serving those customers. And we're pretty excited that it's continuing to function and go, even though we were using this very primitive installation technique. But what this is also showing is the process where we're bonding the cable down in the first pass, and the second pass is that top coat I talked about, where it really blends it into the surface and makes it almost disappear. It's kind of cool to see the early functional prototype still actually providing services to this day. Another case study we did at Dulles Airport, we had 2 rental car buildings that needed a connection made. There was a contractor that was supposed to make it by a certain date. And if you know about airports, there's a lot of other utilities in the ground. It's probably a very time-consuming, permit-wise process to get permission to trench or dig at an airport. But we were able to just show up and over the course of a night, make a connection between 2 buildings. One of the other challenges was they needed that connection made without disrupting their 24/7 rental car return operations. And so we were able to make this link with people trying to return cars all during that process. We didn't have to cut into the ground, so the permitting process was very easy. The airport permitting team, or whoever they are, they just approved it, basically once they understood what we were doing. And we made this connection again in a single night to meet a deadline that one of our customers had. So it was another great use case, another great example. To kind of continue in that same vein, we had a customer that needed a connection made across a bridge in Ohio. And so we built sort of this custom machine to enable us to go across the bridge. We went on the north side of the bridge and on the south side of the bridge. We engineered how to pass over the expansion joints. And we were able to provide 96 fibers across this bridge. Today, and this was last year, and so it went through the winter. We actually had a snowplow run over the line, and it's serving customers in a new community development that went up over on the other side of the bridge, and it's also serving a cell phone tower right now. So again, it's just another example of how we can respond quickly to immediate needs and make a connection happen for people. We're also working with the Air Force. So this is just a picture of our latest machine. It's come a long way since the garage build prototype. And in fact, it's even different looking than what this picture shows. This is, again, still our prototype machine. We've built 3 of these. Actually, we're taking our 4th machine next week, and we're building one more, and that'll fulfill our 5 contracts that we have, one with the Army Corps of Engineers, one with the Air Force, and then we built 3 machines under a National Science Foundation SBIR Phase 2 to sort of test our commercial customer model and market. And kind of leads me to our distribution model, what we really think, how this is really going to get it out there into the world and become a standardized thing. Early on, we're thinking we would be a fiber installer, and what we found is that we were doing a lot of other work that wasn't related specifically to FiberTRAX. So we were running cables and ceilings and mounting conduit and junction boxes and doing some trench work to get to those paved surfaces. And we realized, let's not focus on that. Let's actually move and focus on building the equipment, providing the training and certification on how to use it, and then distributing this equipment out to anybody that can use it, whether it's a municipality, a fiber installer, an ISP, providing the tools for them to utilize this technique wherever and however it makes sense for them. Basically providing another tool in the tool bag for them. And so that's what we're doing. We're marching up to our goal of getting to leasable machines. The Army Corps is very interested in this for sort of on-base fiber deployments and connecting security cameras and maybe some tactical deployments. The U.S. Air Force is very interested in this because on Air Force bases, you don't want to trench, and especially you don't want to trench out to on the flight lines where there's aircraft, but those aircraft need connectivity. The people performing maintenance on them need connectivity. And from our research, it's shown to be very, very desolate in terms of connectivity. And so it's going to save a lot of man hours by having direct connectivity out to where the aircraft are parked and can be serviced. So we're again, continuing to work with the Air Force and try to solve some of their problems. And then through the National Science Foundation, we're building 3 additional machines to kind of test our business model and provide the equipment out to our customers and get feedback on the prototype, what needs to change, what needs to be improved, but what's working well, and how to sort of build out the rest of our infrastructure. We delivered our first commercial prototype to Ohio, I think it was last week, and we're delivering our second one to Texas in a few weeks. And then our third one's going to a company in Florida. And we think these are all of them are different types of companies. So there's a distributor, there's an ISP, and there's a fiber installer. And so we're really testing the business model. We're testing a lot of geography. But you know, our thinking is this is going to become a new standard way of laying fiber. And we're pretty excited to see what the next steps are going to be. Because with fiber, there's just so much you can do with it. It can connect to a bunch of different things, whether it's virtual learning, traffic control, the 5G antennas I mentioned. We think there's going to be a huge way to connect to autonomous vehicles by being on and near the road. We can connect to antennas and backhaul data near the edge and provide better connectivity to those vehicles. Certainly telehealth. Military applications I touched on, and then there's a response to disasters, whether it's a hurricane or some other disaster where you lose your network. We think having a capability to quickly redeploy a network and get up and running and get people communicating is going to be another use case for our technology. So there's just so much that we can do with fiber. We're pretty excited about all the different markets that we can touch and interact with, because we are that infrastructure piece. We're that piece, that physical layer that everything else rides on. All the other technologies need to ride on. And so it's kind of cool to have a new innovation in a field that for the last 100 years, everybody's been burying cables underground or hanging them on telephone poles. There's never really been recently a new innovation in the physical layer for fiber laying. It's not the sexiest industry in the world, but we're trying to change that a little bit. But that's really what we're trying to do to help close the digital divide right now. We already are deploying these machines, but we're looking to get help from people like you that are watching, that are interested, that could potentially help us find and identify pilot projects. We really need to get industry adoption. So understanding that this is a tool that anybody can use. It's not going to replace trenching and burying cables in every case, but it can certainly augment it and help solve a challenging area that you need to pass through, whether there's rocks underneath or other utilities. And it's really just meant to augment that and really extend the reach of where those networks can reach today by helping close even some of the budgets and costs that are coming. This is getting broadband delivered is bipartisan issue. It's a major issue that both sides of the aisle are trying to solve, and they're throwing lots of money at to try to help solve it and build out networks. So we definitely want to be a part of that discussion and be a solution that other people that already have these networks can use to build upon and extend the reach and go further and connect more people together. So I think that's my last slide. I can be reached at daniel@traxyl.com. Really, really appreciate the time today, and look forward to hearing your thoughts on it. And thank you, One Business World, for providing me the platform to speak today. So thank you.
Awesome. Thanks, Daniel. Really interesting topic. One that, you said isn't really the sexiest thing, but I think anybody that's struggled to get a decent internet connection and wondered why that is, probably should be interested in what you guys are doing. So
Totally.
Awesome technology. Excited to see where you guys go with continued funding and your next iterations of your equipment. So thanks for coming on and being a part of the leading entrepreneurs of the world today. Really appreciate your time and patience with this. And so wish you all the best in the future.
Thank you so much, Jonathan. I really appreciate it.